Alright, so is 144 divisible by 6? For 6, if I know the rule that if a number is divisible by 2 and a number is divisible by 3, then I know that it will be divisible by 6. So if I look at 144, it ends in a 4, which is an even number, 0, 4, 0, 2, 4, 6, or 8. So it ends in a 4, so it is divisible by 2. Next, I can look at 144 by taking the sum of its digits. So I take 1 plus 4, which equals 9. 9 is divisible by 3 because there's no remainder. So it is divisible by 3. So 144 is divisible by 2, and 144 is divisible by 3. That means that 144 will be divisible by 6. So I have to make sure that I say yes or no, and then I have to explain why. There is another option that would be correct. I would have preferred that you knew the divisibility rules for 2, 3, and 6. You could take 144 and you could divide it by 6. If you divide a number by another number and you have no remainder at the end with a whole number quotient, then that means that the dividend 144 is divisible by the divisor of 6. And you could explain it by saying, yes, I divided it by 6. Sometimes you didn't get credit because you didn't explain properly how you got that, or it was confusing in your explanation as you're writing these. These problems are in no particular order. I think they follow one of the tests but not the other. This one gave a lot of you trouble. You have to be studying your vocabulary. This is something you could be doing nightly at home. One is the multiplicative identity. Also, when I've met with some of you, you skipped this page in the book. And going through the whole book prior to a test and also as you're doing a lesson is important. Any number that you multiply by 1 is going to be the other number, which makes sense to you, but you didn't know that there's the name. So that's called the multiplicative identity. Also, one of the videos to study for the test, one of the videos just had me going through this very same thing. So an example would be 7 times 1 is 7. For Salvatore, with his 50 comic books, the distinct factors, I can always list 1 and the number itself. It's even, so I know it'll go with 2 and 25. And then it ends in a 0, so I know that'll be 5 and 10 in this case. I draw my rainbow diagram. If you're drawing a rainbow diagram and there's something that doesn't match up quite right, then you've probably missed a factor. And so that's just matching up the factor pairs. 50 is not a square number. It's not a square number because there is not a factor, a whole number factor, that you multiply by itself to get to 50. The other explanation that I really like is none of the arrays for 50 is a perfect square or is a square. Some of you got hung up on perfect square. That's the same thing as square number. I recommend you watch this a few times as you go through your work. If you are doing the retake, or if you are doing the retake test, it's going to be similar but not the same. Some questions will be a little bit different. Numbers might be a little bit different, but the types of questions are going to be very, very similar. 50 is a multiple of 25. If I count by 25s, 50 will be on the list. We have to read these questions carefully. I think you got the idea confused that 25 is not a multiple of 50, but 50 is a multiple of 25. If I was to take 25 times 2, I would get 50. For the Venn diagram, we've been practicing this in class. I want you to think about if you've been writing down everything we've been going through, and prior to a test, going through your notebook with all of the things we do as warm-ups. I'm giving those for a reason, to review things, and if you're writing down what I do as we go through class to adjust yours to make yours better, You will have seen many of these. In fact, I think we've actually done this very same one in class. So I'm just going through each of the numbers because when it says between 1 and 25, I have to include all numbers from 1 to 25. I scored this as 4 points. 1 point for all of the numbers that were outside of the two sets, 1 point for all of the correct numbers in the multiples of 2, 1 point for all of the correct numbers in the multiples of 5, and 1 point for all of the correct common multiples. And that's the overlapping region. And those are the common multiples of 2 and of 5. Sometimes some of you got confused between multiples and factors. Multiples is counting by the number. Factors are the numbers that multiply together to get that number. The ones in the middle are common multiples. The numbers on the outside are not multiples of either or neither 2 or 5. The common multiples are going to be 10 and 20. And you needed to have both of those. For the divisibility chart, I graded it based on if you got all of them correct for a particular number. So for 2, it had to end in 0, 2, 4, 6, or 8. So I just looked at the end, and then I just put check marks there. And that was out of 1 point. For 3, the sum of the digits has to be divisible by 3. So 7 plus 6 plus 0 is 13. That's not. 2 plus 1 plus 0 plus 6 is 9, and so on. I just added the digits up. If it was a number that I could divide evenly by 9 or by 3, then it's divisible by 3. For 4, we did that one together, and the last two digits, and it's in your book, have to be divisible by 4, and then the whole number is divisible by 4. So 60 for 760 and 64 are both divisible by 4. For 5, if it ends in a 0 or a 5, then that number is going to be divisible by 5. For 6, as we went through in the 144, it has to be divisible by 2 and by 3. So I just looked at the numbers that had check marks for 2 and 3. For 9, the sum of the digits has to be divisible by 9. So very similar to the rule for 3. And last, for 10, it has to end in a 0. And there is one there that ends in a 0. And each of those was worth 1 point. The prime numbers on Terry's list. A prime number has exactly 2 factors. I've been talking about how 1 is special, so 1 should not be on this list because it only has 1 distinct factor. So now I'm listing the ones that have exactly 2 factors. So you should have those 4 numbers, 7, 19, 23, and 31. Like I said, 1 should not be there. A composite number has to have more than 2 factors. Once again, 1 is not on the list, and then the ones that were prime can't also be composite, so I'm just listing the ones that were not prime. And so you should have 4, 14, 15, 16, 20, and 28. Perfect squares, the same as a square number. So if I think of it, 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, and so on, a factor times itself will equal a square number. So 1, 4, 9, 16, 25, 36, 49, and so on are going to be square numbers. On the list, there's a 1, there's a 4, and there's a 16. Most of you forgot to include the 1.